Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Physics Chapter 4, Refraction of Light at Plane Surfaces. We will be discussing the topic Refraction of Light through Prism. What is refraction and the refraction through glass slab we have discussed in the previous session. If you haven't watched that video, go watch it first. Today we will be discussing this topic and related questions. What is a prism? Here you can see it is a material which splits white light into its constituent colors, or we can define a prism as a transparent medium bounded by 5 plane surfaces with triangular cross section. Okay, this is how a prism looks like. Here we have 2 triangular faces. A, B, C is the front face, and parallel to it you will be having a face at the backward, that is D, E, F. This is how we are naming. Okay, we have 2 triangular faces. Okay, and we have 3 rectangular faces. 3 rectangular faces. Here D, A, B, E is the one face. Then D, F, C, A is the second face. These 2 faces, these 2 rectangular faces are inclined to each other. They are inclined to each other at some angle. Okay, what about the triangular faces? First triangular face and the second triangular face, they are parallel to each other. Then we have a base. Here the base is B, C, F, E. B, C, F, E is your base. Okay, got the 5 faces. Now, when you draw a ray diagram, you will be just drawing like this. That is triangle. Let's say ABC, which is known as a principal section. So, when you draw a prism for a ray diagram, you will be just drawing the front face. That is ABC, triangle ABC. Okay. Now, light will be falling on these faces. That is the refracting faces. These rectangular faces are known as the refracting faces. D, A, B, E and D, F, C, A are the refracting faces. Light will be falling here and the refraction will be happening at these faces. Okay. Now, here we have an angle. This angle is called angle of prism. Angle BAC is the angle of prism. So, these are the basic ideas about a prism. Okay. BAC is the angle of prism. As we said, here we have taken the principal section, that is the front face of a prism. Okay, to draw a ray diagram, we just need to consider the first triangular face A, B, C. Okay, when a light ray falls on it, what is this light ray called? This ray of light is called incident ray. Okay, incident ray is the ray of light that falls on the first refracting face. Now, we will be drawing a normal. To this refracting surface, you will be drawing a normal. Normal is a line which is at an angle 90 degree with the refracting surface, or it is at a perpendicular to the refracting surface. The angle that is made between this normal and the incident ray is called angle of incidence. This is your angle of incidence. In case of glass slab, we have discussed all this. Okay. So, this is your angle of incidence. Now, the light ray is going from a rarer medium to a denser medium. So, this prism is made up of a glass. Okay. So, this is a denser medium. This is a rarer medium. Rarer medium to a denser medium. Here we have air and this is glass. What happens to the light ray? Bends away from the normal or towards the normal. So, when light travels from a rarer to a denser medium, it will be traveling, it will be bending towards the normal. Here we have normal. What is the actual direction of the light ray? This is how the light ray should go. Okay, this is how the light ray should go. We know light travels in a straight line, rectilinear propagation of light. But what happens when it travels from one medium to another medium? It bends either towards the normal or away from the normal depending on the density. Okay. So, here it is from a rarer to denser medium. Therefore, the light ray will be bending towards the normal. Towards the normal. Okay. This is your refracted ray. Okay, angle made between the refracted ray and the normal is called the angle of refraction, represented by R. Okay, here we'll be taking the incident angle as I1 and the first refracted angle as R1. Okay, now we know that here when the light reaches this refracting surface, again to emerge out, it should travel from a denser to a rarer medium. Okay, so when the light ray reaches here, we can draw the normal to the surface. So this is your normal at 90-degree angle. Now what happens to the light ray? Bends towards the normal or away from the normal. So this is how the actual light should go. Okay, since it is from a denser to a rarer medium, it bends away from the normal. So let's say this is your direction of light ray. There is an angle made between this ray and the normal. And this ray is called emergent ray. Okay, this is your emergent ray. The angle made between the emergent ray and the normal is called angle of emergence, represented by I2. And this angle between the refracted ray and the normal here to this refracting surface is the second angle of refraction, which is represented by R2. So when you extend these two, they will be meeting at a point. Also, we are going to extend this emergent ray. Okay, we are going to extend this emergent ray. Okay, so this extended emergent ray and the extended incident ray, they will be meeting at a point. An angle is made there. This angle is called angle of deviation and it is represented by delta. Clear? Okay, so here we will be having angle of incidence I1 and angle of emergence I2, or you can represent it as I and E. Angle of incidence if taken as I, you can take the angle of emergence as E. Okay, then you have the refraction angles. Angle of refraction R1 and R2. Now the angle of deviation is represented as delta. Okay, what is angle of deviation? Angle of deviation is the angle between the direction of incident ray and the emergent ray. This is the actual direction of incident ray. Okay, here we have extended the emergent ray. At one point they will be meeting and an angle is made between them. This is your angle of deviation. Clear? Okay, you know how to find the angle of deviation now. Refraction of light through a glass prism. Here we have taken the principal section of a glass prism, that is a triangular part ABC. Okay, BAC, we'll mark it as A, is the angle of prism. We have a monochromatic light which is incident on the face of a glass prism. So here OP is the incident ray. Okay, OP is incident ray. When it touches this point, that is when it is incident from this point, what happens? It is traveling from a rarer medium to a denser medium. When light travels from a rarer to denser medium, what happens to the light? It bends towards a normal. So this is your normal. Normal is a line which is drawn perpendicular to the face. Okay, here you have 90 degree. So here we have the normal. This is the actual path of light. With dotted lines we have marked. This OL is the actual path of the incident light. What happens to it then? It bends towards the normal. Okay, from this actual path, here you have the normal. It bends towards the normal. Okay, so this is your refracted ray. PQ is your refracted ray. Okay, then the angle at which the light is incident is taken as I1, the angle between incident ray and the normal, I1. Okay, then the angle between the refracted ray and the normal will be equal to R1. First refraction is happening here. Now this light ray, that is the refracted ray, is incident on the next face. Okay, here what is happening? The light is traveling from denser medium to a rarer medium. When it travels from a denser to rarer medium, here glass is the denser medium. First case, air to glass. And the second case, glass to air. Denser to rarer medium, what happens? It bends away from the normal. Okay, so this is your refracted ray. Refracted ray touches this point. Okay, then it comes out to air. What happens? Here you have the normal. Okay, so the light should have gone in this way. What happens to the light ray? It bends away from the normal. This angle between the refracted ray and normal is taken as R2. Okay, and the angle of emergence, the angle between emergent ray and normal is the angle of emergence. Either you can represent it by E or you can mark it as I2. Okay, I1 is the angle of incidence, R1, R2 are the refraction angles, and I2 is the emergent angle. Okay, so this is the basic things. Now you have the incident ray extended. Okay, and this is your emergent ray extended. There is an angle, and this angle is angle of deviation. We have discussed it. So here first deviation happens at this position and the second deviation happens at this position. Here this was the actual path. From the actual path it is traveling through this line, which means there is a shift. Okay, this is the shift which is taken as delta 1. Okay, here again the same thing is happening. This was the actual path. There is a shift which is taken as delta 2. Now to start the derivation, you will have to consider this triangle MPQ. Okay, M is a point where the emergent ray extended meets the incident ray. Okay, to construct this angle, that is the delta, angle of deviation, we are marking this M. Okay, P is the point where the light is incident on the face of the prism, and Q is the point from which the light goes out of the prism. Okay, so MPQ, consider triangle MPQ. For a triangle, we know that the exterior angle will be equal to sum of interior opposite angle. Now consider this angle LMQ. LMQ is an exterior angle. Angle LMQ is equal to angle MPQ plus MQP. Okay, these are the interior opposite angles. MPQ plus angle MQP. What is LMQ? LMQ is equal to delta. Delta is equal to MPQ. MPQ is delta 1 and MQP. MQP is delta 2. Okay. So we have delta is equal to delta 1 plus delta 2. First thing. Okay. Now, here when you consider this normal and the incident ray extended, these two lines are meeting at this point. Therefore, we can say that the angles between them will be vertically opposite angle. Two lines are intersecting at a point, you have vertically opposite angle. Therefore, this angle I1 will be equal to delta 1 plus R1. These are the two lines. First angle is this and the second angle is this. Okay, these are the two vertically opposite angles. So, we will be having I1 is equal to delta 1 plus R1. Okay. Similarly, when you consider these two lines, normal and the emergent ray with extended emergent ray, you will be getting I2 at delta 2 R2. Okay. I2 will be equal to delta 2 plus R2. Okay. This is taken as A, this is taken as B. Now, this A and B, we are going to substitute in 1. What do we get? Delta is equal to, what is delta 1? From A, we will be having delta 1 is equal to I1 minus R1. Okay. Similarly, from B, you will be having delta 2 is equal to I2 minus R2. Delta 1 is I1 minus R1, delta 2 is I2 minus R2. Therefore, delta is equal to I1 minus R1 plus I2 minus R2. Okay. Delta is equal to I1 minus R1 plus I2 minus R2. Now, removing the brackets, we get delta is equal to I1 minus R1 plus I2 minus R2. Okay. I1 and I2 taken together, I1 plus I2. Here we have minus R1 and minus R2. Minus is common, taking out, you will be getting R1 plus R2. Okay. So, this is a relation for delta. Delta is equal to I1 plus I2 minus R1 plus R2. Now, you have to consider this quadrilateral APNQ. Consider quadrilateral APNQ. NQ. How do we get this N? N is when the two normals meet at a point. Okay, two normals when extended, they will be meeting at a point, and this point is N. APNQ. In this quadrilateral, we know that APN and AQN will be equal to 90 degree. Why? Angle APN is equal to angle AQN, and that will be equal to 90 degree. What is the reason? Because this is a normal and this is also a normal. Okay. So here, when you consider this quadrilateral, normal makes an angle of 90 degree with the plane. So this angle is 90 degree. Here again we have a normal. This is the plane. The angle is 90 degree. Okay. Two angles we got 90 degree. We know the sum of all the angles of a quadrilateral will be equal to 360 degree. Here we'll be having angle APN plus angle AQN plus angle PAQ plus PNQ will be equal to 360 degrees. Okay, we have APN 90 degree, AQN 90 degree, which means their sum will be equal to 180 degrees. This part will be 180 degrees. Okay, taking this 180 degrees to the opposite side, plus 180 degree becomes minus 180 degree. Then you will be having angle PAQ plus angle PNQ is equal to 360 degree minus this 180 degree, which is 180 degree. Okay, what is PAQ? PAQ is the angle of prism. We are considering a prism's principal section ABC, and the angle of prism BAC is taken as A, which is the angle of prism. Okay, PAQ, angle of prism A plus PNQ is equal to 180 degree. Okay, from which we can write angle PNQ is equal to 180 degree minus A. Okay. Next step, we are going to consider another triangle, triangle PNQ. Okay. Consider triangle PNQ. In this triangle, we know the sum of the angles should be equal to 180 degree. We have R1 plus R2 plus angle PNQ is equal to 180 degree. Or we can write angle PNQ is equal to 180 degree minus R1 plus R2. Okay. Taking this R1 plus R2 to the opposite side, we will be getting angle PNQ is equal to 180 degree minus R1 plus R2. Okay. So, in these two relations, we are having left hand side angle PNQ. Okay. If left hand sides are equal, right hand sides should also be equal. Therefore, we have 180 degree minus A is equal to 180 degree minus R1 plus R2. 180 degree can be cancelled from both the sides. Negative signs can be removed, which means angle of the prism will be equal to R1 plus R2. Okay. A will be R1 plus R2. Now consider this relation. Here we have delta is equal to I1 plus I2 minus R1 plus R2. What is R1 plus R2? R1 plus R2 is equal to angle of prism A. That is A. Okay. On rearranging, taking this minus A to the opposite side, you will be getting delta plus A is equal to I1 plus I2. So, this is your derivation. You will be getting a relation between angle of deviation delta and the angle of prism, which is equal to sum of the angle of incidence and the angle of emergence. Okay. Delta is equal to I1 plus I2 minus A, or A plus delta is equal to I1 plus I2. So, this is the derivation. It is very important in every question papers you can find this question. So, be thorough with this derivation. Okay. So, what are the concepts that we are using? We should be using the concept of vertically opposite angle, the maths behind this. Vertically opposite angles, then sum of interior angles of a triangle, then exterior angle is equal to sum of interior opposite angles. Considering the quadrilateral, total sum is equal to 360 degree. All these concepts should be used. Clear? Now we know what is angle of deviation. Now what are the factors on which angle of deviation depends? Factors affecting the angle of deviation. The angle of deviation depends on the following 4 factors. There are 4 factors. First one is angle of incidence. When angle of incidence is increased or decreased, what happens to the angle of deviation? Delta. Okay. Second, the material of prism. Material of prism, it is mainly depending on the refractive index. Denser medium or rarer medium. Light traveling from a rarer to denser or denser to rarer. More refractive index. This is what it means. Okay. What happens to the delta value? Next, the angle of prism. Angle of prism A. Okay. When the angle of prism is increased or decreased, what happens to the angle of deviation? The fourth is the color or wavelength of light used. So, you are using a monochromatic light or whatever light it is. Depending on the color and wavelength, what difference happens to the angle of deviation? Delta. Okay. Let's see one by one. In order to understand the dependence of angle of deviation on the angle of incidence, we will be constructing a I delta curve. Okay, incident angle and angle of deviation is considered and a graph is constructed. So here, angle of incidence is taken along the x-axis and angle of deviation is taken along the y-axis. For this, you will be taking different incident angle values and note the angle of deviation at these angle of incidence and plot a graph. Okay, we are first increasing the angle of incidence from a minimum value. When we are increasing the angle of incidence, that is the angle between incident ray and the normal is increased. Here you have I1, let's say it is 30 degree. From 30 degree you have increased to 32 degree, 34 degree. That is initially when you are increasing, what happens to the angle of deviation is angle of deviation delta will decrease. Okay, initially that is what you are representing here. The angle of incidence is increasing, angle of deviation is decreasing. Okay, at a particular angle of incidence, what happens is the value of the angle of deviation becomes minimum. That is, on further increasing the angle of incidence, the angle of deviation from now on will only increase. It won't decrease. Okay, so this minimum value of angle of deviation is taken as delta minimum. Okay, at this delta minimum, what is happening? This is the value from which on further increasing the angle of incidence, there is no decrease in the angle of deviation. It will start to increase from then on. Okay, so at this point, you will be having the angle of incidence and the angle of emergence equal. Okay, at this point, from this point, when you draw a perpendicular to the x-axis, you will be getting an angle of incidence value. Yes, this value will be same as the angle of emergence as well. I1 is the angle of incidence and I2 is the angle of emergence. So, these two values will be equal here. I1 will be equal to I2. Okay, when I1 and I2 are equal, at that place, you will also be having R1 equal to R2. Okay, I1 and I2 will be equal, angle of incidence and emergence will be equal, R1 and R2 will also be equal. So, we have delta is equal to I1 plus I2 minus angle of the prism A. Here we have the angle of prism A. Okay, so minimum value is when I1 and I2 becomes equal. If I1 and I2 is taken as some I, okay, then you will be having I plus I, 2I. 2I minus A is the minimum value of angle of deviation. Delta minimum will be equal to 2I minus A. Okay, delta minimum. This is how you can find the angle of minimum deviation. Okay, one more point to remember, the position of a prism with respect to the incident ray at which the incident ray suffers minimum deviation is called position of minimum deviation. That is this position. Here, let's say at this position, we are having an angle of incidence that is equal to the angle of emergence, which means it is suffering the minimum deviation. This position is called the position of minimum deviation. Clear? So, this is the thing. This is how the angle of deviation depends on the angle of incidence. Okay. One more point to remember here is when you consider the position of minimum deviation, at this point when you draw the refracted ray, here you have the refracted ray, this refracted ray, we know R1 will be equal to R2 at this point. Yes, here R1 will be equal to R2, as we said I1 is also equal to I2. You will be having the refracted ray, and this refracted ray will be parallel to the base of the prism. So here you are considering an equilateral prism, or if you have the principal section, that is considered to be an isosceles triangle. In any case, isosceles means two sides are equal. In any case, you will be having the refracted ray will be parallel to the base BC. Okay, only when you are considering the point or the position of minimum deviation. Under the condition of minimum deviation, you will be having I1 equal to I2, R1 is equal to R2, and then the line, this line, that is a refracted ray, will be parallel to the base BC. Okay. The second factor is the dependence of angle of deviation on the material of prism, which means the dependence of angle of deviation on the refractive index mu. Okay. For a given angle of incidence, a prism with a higher refractive index produces greater deviation than a prism which has a lower refractive index. Consider two prisms. Here, this is your first prism and this is your second prism. Okay. Here we have the incident ray. This is your incident ray. This is your normal. And here you will be having the angle of incidence. Again, this is your normal. You have angle of incidence. Now consider the first prism has a refractive index mu1 and the second has a refractive index mu2. Let's say that the refractive index of the first prism is greater than the refractive index of second prism. Okay, here the first prism has a refractive index which is greater than the refractive index of second prism. Now, what happens when light travels from a rarer to denser medium? We know that this is the actual path of light. Okay, this is how the light has to be traveled. But what happens when it travels from a rarer to a denser medium? It bends towards a normal. Yes. So, when refractive index increases, the bending also increases. Which means, let's say for the first, this is your refracted ray. Okay. It bends towards the normal. Here we have the second prism such that the refractive index is smaller. Which means the bending is less compared to the first case. Okay. This is the actual path. Okay. Let's say this is your refracted ray. Okay. Angle between the normal and the refracted ray is angle of refraction. Here you have angle of refraction and this is the refraction angle in this case. Okay. Now, when this light travels from the denser to rarer medium, what happens? It bends away from the normal. Here we have the normal. This is your normal, 90 degree. It bends away from the normal. Here the refractive index is more. Therefore, bending will be more. Let's say this is your emergent ray. When emergent ray is extended, I'm extending this emergent ray. Here you will be getting an angle delta. This is a deviation in this case. Okay. Here again, this is your glass. Light is coming out of glass, that is emerging out. Here you have the emergent ray. Okay. And emergent ray, how is it moving? From glass to air, which means a denser to rarer medium. This is your normal. Okay. Light will be bending away from the normal. This was the actual path. It is bending away from the normal. You will be getting the emergent angle when extended. This when extended, you will be getting an angle of deviation in this case. We have refractive index of the first medium greater than the refractive index of second medium. When you check these figures, you will be understanding that the angle of deviation is maximum in the first case. Okay. Here compared to this second glass, angle of deviation is maximum here, which means the angle of deviation del 1 is greater than del 2. Okay. Delta 1 is the angle of deviation in the first prism and angle of deviation in the second prism is taken as delta 2, which means we can say that when refractive index increases, what happens to the angle of deviation? Angle of deviation also increases. They are directly proportional. When the refractive index decreases, angle of deviation also decreases. Okay. Now, if you are taking the case of a flint, now if you are considering a flint glass and a crown glass. Okay, the refractive index of the flint glass is greater than the refractive index of crown glass. In which case do we have the angle of deviation higher? Angle of deviation will be greater for the flint glass compared to the angle of deviation in the crown glass. Okay, understood the dependence of the angle of deviation on refractive index or material of prism. Material of prism means it means the refractive index. It is depending on the refractive index. Okay, this is your second factor. Now the third factor is angle of prism. If you have two prisms, this is your first prism. Here you have an angle A, which is the angle of prism. You have another prism with a greater angle of prism. Okay, so in the second case you will be having angle of deviation higher. This is how the dependence is. When angle of prism increases, the deviation, that is angle of deviation, will also increase. If the angle of prism decreases, angle of prism is smaller, the angle of deviation will also be smaller. Now the fourth point, the color or wavelength of light used. Here if you consider Vibgeo, okay, violet, indigo, blue, green, yellow, orange, red. Which light has the maximum wavelength? In this case, maximum wavelength is for red light. Okay, red light has the maximum wavelength and minimum for violet light. Violet light has minimum wavelength and red light has maximum wavelength. We have refractive index of the second medium with respect to first medium is equal to mu2 divided by mu1, refractive index of the second medium by refractive index of first medium, that is equal to velocity of light in first medium by velocity of light in second medium, that is equal to wavelength of light in first medium divided by wavelength of light in second medium. We have studied this relation in the previous class. Okay, which means we understand that refractive index is inversely proportional to wavelength. Wavelength increases, refractive index decreases. Okay, so here we will be having minimum refractive index for maximum wavelength red light, and the refractive index will be maximum for the minimum wavelength violet light. Now when you consider this figure, you will understand that in which color light the bending is more? Light bending is more in the violet color. Okay, bending is more means refractive index is maximum. Okay, red light bends the least, which means refractive index is minimum. Okay, you also know the wavelength relation. So what is happening? When wavelength increases, refractive index decreases. When refractive index decreases, we have studied the second point, dependence of refractive index, that is dependence of the angle of deviation on the refractive index. They are directly proportional, right? So when wavelength increases, refractive index decreases and the angle of deviation also decreases. Similarly, when the wavelength decreases, refractive index increases and the angle of deviation also increases. Clear? So these are the four factors. Let us do a problem. A ray of light incident at an angle of incidence 48 degree on a prism of refracting angle 60 degree suffers minimum deviation. Calculate the angle of minimum deviation. We have a relation A plus delta is equal to I1 plus I2, where I1 is the angle of incidence, I2 is the angle of emergence, delta is the angle of deviation and A is the angle of prism. When it comes to a condition of angle of minimum deviation, when there is a condition of minimum deviation, angle of incidence and the angle of emergence will be equal, which means I plus I, and the angle of prism will be the same, A. Here what is given? Given that angle of incidence is equal to 48 degree, then the refracting angle on a prism of refracting angle, which means the angle of prism is given, which is 60 degree. Okay, how to find delta minimum, that is angle of minimum deviation is equal to 2 times I minus A, which is 2 into 48 degree minus 60 degree. Okay, 48 degree into 2 is 96 degree minus 60 degree, which is 36 degree. Okay, the angle of minimum deviation in this case is equal to 36 degree. If you just know the formula, substitute the values, you will easily get the answer. Second problem, what should be the angle of incidence for a ray of light which suffers minimum deviation of 36 degree through an equilateral prism? Equilateral prism is a prism in which the angle of prism is equal to 60 degree. Angle of prism is 60 degree given angle of minimum deviation is equal to 36 degree. Okay, we have angle of minimum deviation is equal to 2 times angle of incidence minus angle of the prism. We need to find I, which is the angle of incidence. We will be having 2 times angle of incidence is equal to angle of minimum deviation plus angle of the prism. We are taking this minus A to the opposite side, it becomes plus A. Then the angle of incidence is equal to angle of minimum deviation plus angle of prism divided by 2. Okay. What is the value of angle of minimum deviation? Given 36 degree plus angle of prism. It is understood that since it is an equilateral prism, angle of the prism will be equal to 60 degree divided by 2, which is 60 plus 36 degree, 96 degree by 2, which is 48 degrees. Okay, just the opposite thing. In the previous question, we were given the angle of incidence. Here, we are to find the angle of incidence. Okay, the values are same. Next, problem number 3. Figure shows 2 identical prisms A and B placed with their faces parallel to each other. A ray of light of single color PQ is incident at the face of the prism A. Complete the diagram to show the path of the ray till it emerges out of the prism B. Okay, here we have 2 prisms A and B. A is an inverted prism. A and B are kept parallel to each other. We have a ray of light PQ which is incident on the refracting face of prism A. Okay, what happens to this ray of light? It is traveling from a rarer medium to a denser medium. Okay, when a light ray travels from a rarer medium to denser medium, we know that it bends towards the normal. Okay, here let us draw the normal. This is the point of incident. Q is the point of incident. When you draw normal, this is your normal at an angle of 90 degree. Okay, what happens to this light ray? This light ray will be bending towards the normal. So here we have PQ. This is the actual path of PQ. But when it travels from this rarer to denser medium, air to glass, it bends towards the normal and this is your path. Okay, this is your refracted ray. Now what happens to this refracted ray? Let's say PQR. R is the point where this refracted ray touches this plane, that is refracting surface, second refracting surface of prism A. What happens? Here it is from a denser medium again to a rarer medium. Denser to rarer medium, light travels away from the normal. Light bends away from the normal. At this point of refraction, we will be drawing a normal. This is your normal. What happens to the light ray? The actual direction of light ray is this. Okay, it will be bending away from the normal. So this is away from the normal. Let's mark this as S. Okay, this emergent ray of prism A comes and strikes the second prism, the first refracting surface of the second prism. What happens here? Again, light is moving from a rarer medium to a denser medium. What happens to the light ray? It bends towards the normal. Let's draw normal. Here S is the point of incidence for prism B. Okay, we have the normal. I have drawn the normal. Now the light ray, actual path. This will be the actual path. Light ray bends towards the normal. So here you will be getting the light ray. Okay, show the direction. You have to put this arrow marks. Okay, so here you have the refracted ray, first refracted ray for prism B. Now what happens? Let's say this is point T. At point T, what happens? Light again goes from a denser to a rarer medium. Denser medium to rarer medium. We'll draw the normal. This is your normal. What happens to the light ray? The light ray will bend away from the normal. Denser to rarer medium, away from the normal. Okay. So this is the required emergent ray. Okay. This is your complete diagram. We started PQ is the incident ray, QR is the refracted ray, RS is the emergent ray of the first prism and RS is the incident ray of the second prism. Then you have the refracted ray ST. Let's mark this as U. TU is the emergent ray. Complete figure with the ray direction of or the path of light ray. Clear? That's all for today. In today's class, we have discussed the refraction of light through a prism. We have studied how to find the angle of deviation, angle of minimum deviation, the factors on which the angle of deviation depends upon. Also, we have solved related problems. Hope you all enjoyed this session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.